Well, let me start with I see people starting to roll in now. Let's not hold everybody up. So again, I'm going to start with my opening patter here. So welcome everybody. This is Doug Meil with Cleveland Big Data, and I see folks rolling in, but let's start on time. So it's May 10th, 2021, and we've got another virtual style meetup. So I'd like to thank everyone for coming. We've got a great agenda tonight. We've got AJ Misra from NASA Glenn talking about aerospace AI applications, David Talby talking about SparkNLP. I'm going to do a short 5-minute blurb on the blockchain challenge context. And then Mark Maslar is going to do the blockchain challenge presentation. And for those that didn't see my multitude of emails on the topic, that's where someone is going to try to explain blockchain to me. And that someone is Mark. So all the talks are going to be 20 minutes and timed, except for mine, and mine's only going to be, I'm going to set a timer on myself for 5 minutes. So with that, let's do a few quick announcements. Again, I still have the meetup approval reminder in terms of the people joining the meetup, just simply because to avoid drive-by spam. Again, I apologize. But it was necessary last year. We had a lot of drive-by spam. I'd like to talk about the friend of the show. So friend of the show is the moniker that I use for people that do presentations for the Cleveland Big Data Meetup. And that is something that once you are a friend of the show, you're a friend for life. You can put that on your resume. It's like an English peerage. It goes with you wherever you go. You cannot, however, gift it to a relative or spouse, but it is yours for life. And so I'd also like to get into the recruiting shout outs now. So if anybody has any recruiting shout outs, if you could put them in the chat, and then we can talk to them and try to hook people up. So, oh, good. I see a bunch of folks now talking. I see a bunch of things in the chat right now. Hopefully, folks. Chris Barrett from Progressive. They are looking for data and analytics jobs. They got a lot of machine learning opportunities, data enablement teams. So all the jobs open. You can look at progressive.com/careers. But yeah, there's a number of data related positions, and also in the machine learning core team. So Chris, do you have any other individual contact information you'd like to cite for people, or just the website? Just the web. Got it. So again, that's progressive.com/careers, and you can look at the job opportunities. Is there any other recruiting shout outs at this time? Going once, going twice. Thank you. Also, there's a quantum computing meetup that Progressive is sponsoring. So it looks like a Northeast Ohio Quantum Computing Meetup group. So check that out. It looks like there's going to be a meetup in July. So for those that are interested in quantum computing, please check that out. And the great thing about quantum computing meetups is that you can be in multiple meetups at the same time. You like that? I work hard at keeping things entertaining here for the members. Thank you, Chris. So with that, let's go to AJ Misra, and AJ, whenever you're ready, I'll start the timer.
Okay, you want to let me share the screen.
I don't see it yet.
Oh, you want me to put my video on?
No, was there a presentation?
Yeah, I'm trying to see how I don't see that on my screen right now. So let me see how do I do that. It is hiding somewhere behind my screens here.
It should be the share screen.
Okay, I'm trying to see. Can you see it now?
It says you've started. Oh, there we go. I'm seeing presentation mode. I'm seeing like
Yeah,
presenter
I'm
mode. Not full
putting it on
screen,
the slideshow right now.
but yeah, but it's I can see the slides and they're clear.
Okay, so you are there?
Yep, it looks good.
Okay. Hey, thank you for the invite, and thanks to Harv Silling from our place who connected me to this group. It's great to be here. A lot of things, as you know, a lot of things. This is an exciting field for everyone, including aerospace. And I myself, by no means, I'm an expert in artificial intelligence. So I'll just give you some general applications what we see. Again, a lot of it is aspirational, not that we are there in everywhere, but we are trying to be kind of apply the artificial intelligence in aerospace quite a bit now, and there's a lot of activities, and with next few years we'll see a pretty big kind of acceleration of these things as we go forward. So with that, so I'm going to talk you guys all know you're experts in artificial intelligence and machine learning. I don't want to tell you about that, but where we see a lot of benefits to us is we do a lot of computational modeling, and it takes a lot of time. I mean, sometimes it takes a day or 2 days to do something. We see a lot of big things is that we can accelerate the speed of computation, what we do in aerospace modeling. And it has given us new ways to design our components that we didn't have the tools before. And so I'll talk about that. And one of the big things in materials is big thing for aerospace, lightweight, extreme environment. Then what the artificial intelligence has given us is how to accelerate our materials design and discovery. And health management safety is big for us. And AI has given us a lot of new insight and how you want to do it. And one big application is our aerospace communications with space and aeronautics, airspace as aircraft travel together. And how do you make artificial intelligence to apply there? That's a big thing. Then digital twin is a real, going to be really big for aerospace and any things, whether it's aerospace or non-aerospace, digital twin is playing a big role. And finally, the autonomous systems. Everything is going to be, a lot of things will be autonomous, as you see in the self-driving cars. So we are on the same path, and I'll give you some examples there. So that's kind of the broad scope that I'm going to talk today, this evening. So start with the, how do we increase the computational efficiency of models? You see, like it has given us a lot of opportunities to increase by orders of magnitude the way we compute things. Left side is an example of NASA's climate change, like you do a lot of aerosol modeling, and that way, like you can look at that, they increase the speed by kind of billion times or million times. Again, because you can take all the physics-based models and you use the artificial intelligence to get some surrogate models or reduced order models, and that way you don't lose much on the efficiency or on the accuracy. You might lose 0.1, 0.5%, but you can speed up computation like crazy. Like for whether it is as you go from atoms to galaxies, finding new planets and exoplanets, other universes, the AI has given us many shortcuts to model things much faster. And right side is an example of one of the composite structures we model from atoms to structures. It is very computationally very kind of expensive. We have to use a lot of computational power to do that. But with some of take the physics-based models and to train them to make your neural networks to surrogate models, and you can we have increased the speed by about 150 times with maintaining 98% accuracy. So this is a big application of AI in speeding up the modeling, whether it's computational fluid dynamics, aeronautics, or materials discovery, or finding new planets in different universe. So this is going to change the way we model things and make it a lot more faster as we go to the future. So this is a big advantage that AI and machine learning has given us in our toolbox right now. Oops. So we talked about new design. Before, we used to design a new product or a new component. We used to make a CAD drawing and to make it and manufacture it and test it and break it and go back to the next iteration. But now with the tools we have on the big data and the AI, ML, we can look at, if you know the requirements, like we find what do you need, then you can get the database of a lot of past designs, similar designs, and big property database that you see here, and a lot of synthetic models we can simulate and manufacturing techniques. So we can collect a lot of data based on past designs, database that we have for past 30 years, and what kind of designs we have. And if you don't have anything, then you simulate, or what you call you get synthetic models based on simulations. So you can take all of them together and apply what you call generative design using AI ML tools. Then you have, in pretty quickly, you have hundreds of options on your new design. That capability we did not have before, that you can create so many designs in one instance based on applying this artificial intelligence. And you can see that once you do that, then you can apply some of the optimization tools that also use AI ML with faster experiments that we can analyze pretty quick. Then you come up with some good designs at the end. So this is changing the way we design our new aircraft components and the whole aircraft power systems. So this has given us a new paradigm in design space completely. And that is a big boon for the design guys to look at a lot of things at one place. Again, this needs a lot of big data, a lot of databases, and integration of a lot of different data sets from designs to data numbers to models and manufacturing things. So that's a pretty complex big data problem we have. And then applying those things by artificial intelligence to find many options at the same time. And this is becoming pretty, kind of becoming not common, but it is becoming pretty growing in many of the companies, including NASA right now. So next one is, I talked about materials discovery. Again, before we used to make a material, process it, break it, and come back to do it again. But now again, same thing, you have the requirements, and then you can take all these tools. We can take a big database that for the last 30 years of similar materials. We can take a lot of microstructures of the images, and you can take a lot of like 50 years of research papers and analyze them to find the connectivities and connect the dots, and then apply the artificial intelligence to plan what experiments you need to do, what is the uncertainties, and what you can predict from these experiments, and recommend what experiments we do. Before, we were kind of in a blind, we just do it and then find something, then do it again. But now in one place, we can find what we want to do and recommend experiments and what you want to get out of it. And then you automate the experiments with robots. And then once you get the results, you can analyze by artificial intelligence, and then you plan the next one. So it can accelerate your materials, new materials discovery for energy storage or aircraft materials or batteries, that it can accelerate pretty fast your material discovery process. Again, because of the AI, ML, and the big data, we can do this now, or beginning to do this now. We are not there yet, but this is becoming the trend in the material discovery for the aerospace application. So again, very exciting way to discover new materials. So another thing is health management. I give an example, like before we had the predictive rules to manage the health. Now we use the machine learning to manage our health. It's an example of battery. We have a lot of, as you know, read that we have a lot of electric aircraft things going on. Like you can take the air taxi from your home to downtown, and that they are all electric by batteries. But you know, batteries catch fire. That we all know that. So you don't want the battery to catch fire when you are in the flight. So we are doing a lot of things to manage the health using machine learning, because you cannot do every experiment, every prediction. So what you do, you have sensors inside the batteries, very tiny micro sensors. You do a lot of non-destructive testing, and you do machine learning to correlate various failure modes and how they degrade. So you can pretty much at any given instant, if you can measure one thing, you can know the health of the battery, or you can know if the condition is right for it to catch fire. So you can stop the airplane at the next stop and take the batteries out. So that's how the machine learning has given us tools to predict the health of the batteries without, and that will give the confidence to the users that they can fly it and they won't be stuck on the air with the fire in the air. So again, this is revolutionizing the health management completely. for many components and also for the whole aircraft. So same thing for the aviation safety. Like we have hundreds of planes flying in the air, and you get a lot of data from these airplanes that those are flying. So a lot of unknowns we have, and we need the machine learning or AI approach to analyze a lot of data we get from these planes. Then you can see which planes might be some defects or there is some anomaly in the flying things, and you can analyze so much data by using AI tools that will make the whole aircraft fleet safe throughout the flight, because then you can identify some conditions that we couldn't do it before because it was computationally very extensive, and now using AI tools, we can analyze flight data from hundreds of aircraft at the same time, and that is going to change the way we manage the airspace operation completely, and we can find the defects or any nothing that unusual things we can identify a lot before that something happens. So that adds to the aviation safety in the airspace system as well. I talked about airspace communications, like the airspace is becoming very complex. You have a lot of different flights happening inside the city, outside the city. As I said, like we have this new urban air mobility where you just take the air taxi, that is electric flight from your home to downtown instead of going through the congested cities like LA, San Francisco, Dallas, New York. So that is a growing market, and you will see another picture next slide, next two slides. But that way you can travel, and so that's your cities will be crowded just like cars with these air taxis that is going to fly in and out of different hubs from ports, suburbs and the downtown. And then you have the normal planes coming out. Then you have the UAVs or unmanned air vehicles, to your drone delivery, your packages by Amazon or UPS deliveries. So those will be happening by drones. So the airspace is becoming very complex, and how do you manage the communications link without human intervention? So that's where you manage the spectrum, manage these channels. How do you want to optimize the channels with different sources? There are so many satellites, and you have the 5Gs and networks. So how do you optimize those channels? And that's where the artificial intelligence comes in to manage the spectrum. If something is not available, it can go automatically to the next one somewhere else, so that you are not stuck without any communications, or it can communicate between aircraft. So that's another thing, that path is open. So you have a lot of intelligent agents on the ground in the plane that will communicate with each other using the AI ML tools, and that will make your sky safe with growing number of planes inside the cities and outside the cities, because that's going to change how we manage the airspace communications from different networks. So again, that's another AI revolution that's happening in the airspace communications area. Same thing with space. I think space, we have a lot more networks now with a lot of satellites, with a lot of space, like we go to Mars, we go to Moon, we go to other planets. So how do you communicate, and so many channels that without the human intervention, can you manage these channels using machine learning and artificial intelligence, so that you can, any given time, you have some channel available for your communication. So again, that's another big application for the artificial intelligence here. Again, it is changing the way we use the aerospace communications, and this is where you guys talked about quantum computing, and this is where the quantum communications is going to play a big role. Again, quantum science is becoming also pretty important here, and it will merge quantum science with artificial intelligence here in the space communications area. So one big thing you all know is the digital twin. I mean, twin is a physical or the digital replica of what you have, like of a human being. It's an example of a GE Aviation courtesy, an aircraft with engines. So you build this physical or the digital model of the physical asset, where you do a lot of complex multi-physics simulations to model everything inside your component or the engine, and you use artificial intelligence to kind of collect data in real time. Like if you have a digital twin in your company, and you are flying the asset like aircraft, and it is giving you constant data like temperature, vibration, sensors, using Internet of Things. So you can pretty much monitor the health of your component or the asset in real time without any delay. So because you have the twin, sitting next to you, and you can looking at all the data, and your twin is becoming a real system of what is flying. So you can manage the when things are going to fail, you can know much before how things degrade, and so you can do a lot of stuff with that, with the preventive maintenance. Before they used to do shut it down for in 6 months or 1 year, but now you only shut it down when you think there is a problem. So that's called preventive maintenance that we can do, and you can measure the health of the asset. So these things we are using to design, as I said, new components, because you can pretty much look at all the variables before you can cut a single metal to make something. So that's the beauty of this digital twins. You can do two things. You can do design, optimize a lot of new products without any single test, and you can do predictive maintenance. And this is all enabled by Internet of Things, big data, cloud computing, and advanced analytics like machine learning and all those things. So a lot of this big data and the machine learning and the Internet of Things are enabling the digital twins, so that you can do digital twin of the aircraft, you can do the whole spacecraft, you can do for the whole NASA Glenn Center, you can do for the whole power grid, you know that. So this is becoming pretty impacting our aerospace business quite a bit. That's where you create the digital twin for doing many things that we didn't have this capability before. So last one is autonomous system that how to make, this is an example of a Mars rover that is going to, there's no humans there, so you have to go and play in the sand. So it has all the onboard systems, and they have the sand structure, sand composition, and it can do a lot of data collection and decide where to go. Probably I can put, there's a movie, but it may not have time to show the movie here. But there is it can take all the data from image processing, your terrains, and decide how to go without an obstacle. So this is the autonomous system that is driven by the artificial intelligence. It has all these GPS, the Mars GPS, Mars, and it has the how to plan your movements. It can image a lot of analysis from the image it is processing, and it knows how to diagnose faults. So it can kind of move around on its own without damage to the vehicle. So that's kind of ultimate in the autonomous system that we fly on the Mars rovers there.
We got 3 minutes left.
Okay. I'm pretty much done. So next is the autonomous system for aircraft. I talked about the urban air mobility, where we'll have air taxis from your home to downtown, and the right side picture, you can see it is Cleveland. You can see that. So this is going to be in 2025. We will have a lot of air taxis in big cities like Dallas, LA. So again, they will have a lot of sensors, but they need artificial intelligence to work autonomously, because you can have a pilot, but that becomes expensive. So the goal is to make it autonomous, and that's where you will need a lot of artificial intelligence to do these things. And so this is the big revolution in the aircraft through this what we call urban air mobility, where there will be air taxis. So then we have this one challenge that we all face with artificial intelligence is that it's a black box, and it is hard to certify these aircraft systems because people don't understand the black box that the neural networks use. So any decisions have to be explained by human to certify these things. So that's a big challenge that we face. We need explainable AI system that is more explainable to the certifiers and human beings. And my last chart. So I think it is going to, artificial intelligence can change how we do aerospace missions. The missions are becoming very complex as we go, with a lot of things inside the missions. So you need the AI to manage these missions, and some of the big data challenges we see. We have lots of data that we need to integrate, multiple types, images, real data, artificial data, and some modeling data. So how to integrate so many sources of data together to create your models and artificial intelligence tools. And we have data from multiple sources with collaborators from different companies, and how to integrate those things in one platform. So those are some of the challenges we are trying to address. And this is exciting field that what artificial intelligence brings to us in the aerospace community. And thank you for your attention.
Awesome. Thank you. Thank you, AJ. So we've got a minute left here. So any questions for folks? And so there's one question already does NASA expecting us to be flying in autonomous air taxis in 4 years?
Not in 4 years, probably, but maybe in 10, I would say 10 years, because 4 years we'll fly air taxis with a pilot in it, and because we won't be certified by then. But we are flying drones now, so the technology is there. It is the public acceptance. It is the certification, but the technology is pretty much there. It is how much public is going to accept autonomous flights, and that's a big thing.
Well, thank you. I have time for one last question. Going once, going twice. Cool. AJ, thank you very, very much for your time, and it's a great presentation. Thank you. Everybody give AJ a hand, either physically or virtually.
Thank you. Thank you very
much. Next up is David Talby with SparkNLP.
Hey, hello everyone. Can you hear me?
Sounds good. I can hear you. I can hear you, David.
Okay, great. Yeah, let me know if when you can see the screen.
Yep, I can see it just fine.
Okay, great. So, Doug, thanks for the invite. Thanks everyone. And by the way, thank you, AJ. I think I really enjoyed this. I was looking forward to your talk as well. So thank you.
Thank you. Yeah, thanks.
Yeah, what I'd like to do is talk a little bit about SparkNLP, which is an open source natural language processing library, which hopefully can help you in your current and future projects.
This is my favorite topic, NLP.
Oh, great. So you're in the right place. It's kind of that meetup. Just a bit about Johnson Labs. Johnson Labs, we're a software company. We are 6 years old, and our focus is on natural language processing in healthcare. So that's where we are commercially. But as part of that, we created the SparkNLP library, and that's our baby, and that's kind of we support the community around that. We're fairly well known in kind of the AI ecosystem and healthcare AI system. But the thing we are most well known for by far is the SparkNLP library, the open source library. And these are kind of the current stats around the library today. So SparkNLP for 3 years in a row now has been the most popular natural language processing library in the enterprise. I think we have like 6 or 7 different kind of industry surveys that support that, but the main one is the O'Reilly Media one. It does, I think, to like 2,000 or 3,000 practitioners worldwide. So basically, what we see in research, we are not the most popular. People use Spacey and Hugging Face and others, but usually in the enterprise, SparkNLP is the most widely used. Specifically within healthcare, based on the latest NLP industry survey from Gradient Flow, the one who asked about it. So 54% of healthcare AI teams use SparkNLP as of 6 months ago. And the latest result, this is and this is just pipeline downloads, grew by 16 times since January 2020. So the library really took off during 2020 and until now. The library is also, we're not counting here other downloads via even just Conda, but also Maven Central, Spark packages, because while Python is the most popular API, the library is also available with full APIs for Scala and Java as well. So that's overall. The library is an open source library, and we'll talk a bit about what it does, and then I'll go and I'll show you some code and some examples. Meanwhile, let's just opening the Q&A, or I'll just keep the Q&A open. But look, if there are any questions, please just ask as we go. And I can see, I see the Q&A. I do not see the chat. Is that how it's? No, now I'll see the chat. Okay, so let's just ask on chat. So I'll have that open. But the first thing I'd like to discuss, when people say, because AI is a hot and buzzword heavy area. Many people say that they do state of the art, they look to that. So we do want to talk about what that actually means, because as you know, we are in a field that's super noisy. So for us, it means 3 things. First of all, it means the academic state of the art, right? Meaning that if you say you're state of the art on a task, meaning like you should have a peer-reviewed paper that's published, that looks at an public academic benchmark that's actually competitive, right? So that others have also already competed on. and you should make some reasonable claim that yes, under these parameters, you're more accurate than anyone who has a peer-reviewed paper has ever been. And you should publish papers and the paper and the code, so that anyone can go and reproduce your results, right? So that's kind of the classic academic state of the art, right? So that's what brings it, at least in the academic sense, right? From a marketing hyperbole to something that's real and reproducible and measurable. On top of that, there are two other things that we kind of take on when we say that we say we have the applied state of the art. Yeah, because we are not in the academic research business. Our goal with SparkNLP is to go and productize research, right? So when we say SparkNLP delivers state of the art, we don't claim to have invented the next version of the next generation of transformers. What we do claim is that we continuously go and read the papers and try to reproduce them, try to generalize them. If something actually works and actually generalizes, our job is to deliver the production-grade, trainable, scalable version of that. So when we look at when we say something is state of the art and production ready, what it should mean is two more things, right? First of all, it actually needs to be in production in more than one organization, which means that first of all, you actually got into production somewhere, right, in a real scalable environment. And the second, it should not be a custom implementation, right? Because of course, always yes, on one data set within one project, you can get state of the art result. But the question is, okay, can you get it in multiple different companies, use cases, data sets, meaning that you actually got kind of the model and the algorithm correct, and it's trainable, tunable, and so on. The second thing requires, look, it needs to be open source or open core. Really just to make sure you've actually built it, right? That you're not just, showing a nice UI on top of something else. And there's actual code to go through with it. So if you look at SparkNLP, what we have now, as I said, our focus as a company is on the healthcare side. So right now, especially for clinical and biomedical NLP, if you go to Papers with Code, which is the Facebook site that right now tracks over 4,000 different benchmarks, right? And about, I think there are, of course, 40,000 papers right now. If you go to medical name identity recognition, we're the top, we're the top most accurate for 8 of the 11 benchmarks. And there are other ones in other categories that we have as well around relationship extraction, around assertion status detection in healthcare. So for at least, we can point to specific tasks where, yes, we have papers, we have results, we have code, it's reproducible. The other thing with SparkNLP, and this is something I'd recommend that you do if you're looking for more examples. We have not just papers or kind of marketing examples, we have actual technical case studies, and everything you see here are things that were presented in things like O'Reilly AI and Strata Data and Spark Summit and Open Data Science Conference. Also, I think like 1 or 2 were also in the NLP Summit, right, which is kind of what we organize. But the point is, those are actual technical talks. They talk about real-world use cases, and if you have a use case that's similar, this is a great place to start from, because when you have a real machine learning or deep learning or NLP project, usually your main problem is not just the NLP models, right? And yes, that's the cool part where yes, we use deep learning and transfer learning, and we use these cool embeddings, right? And we scaled it in an interesting way. But really, what you need to start from always is, really, what was the business use case? Where was the data? What were the problems with the data? What were the other problems with the data, right? How do we tune something that's reasonably generalizable? How do we measure it, right? And then how do we make sure that it actually keeps improving in a real-world system? And some of the use cases here would really focus exactly on that. I mean, if you look at the Kaiser one, the Roche one, a lot of it about, if you look at the Roche title, so it's automated and explainable deep learning for clinical language understanding, right? Where the two options, first of all, how do you automate it, right? So we made it work for one hospital. Now we want to scale it to tens or hundreds. How do we do automated tuning? And then, of course, the explainable bit is important as well, because you need to convince clinicians to actually use the results you show them. So that's also a lot of what we focus on, actually putting these things as part of real systems. And the third important thing is you need to make sure the library is actually production ready. Means it means more than doesn't have bugs or doesn't have major bugs. It means it actually is heavily optimized for what people actually use. And we do a lot of work on just profiling, optimization, memory management, runtime, those aspects. So SparkNLP 3 is the latest major release. We announced it, I think, 6 weeks ago now. And that was the results of 4 months of pretty intensive profiling. So this version, first of all, it supports Spark 3. But then, as you can see, we've done major work here. And by the way, we work both with the NVIDIA technical teams and the Intel technical teams. So Intel, it's more on NLK. With NVIDIA, they work on Spark Rapids. And they make Spark 3 actually GPU aware. So we've done some work with them to actually get the speed ups as you see here. So this is SparkNLP 3 versus the previous version, which was 2.7. As you can see, we're almost 8 times faster on calculating BERT large, and about 3 times faster on calculating name entity recognition, which is the most common tasks. The other thing that we did a lot of work on, a lot of testing on in SparkNLP 3 is making sure that we have these kind of turnkey integrations with really all the major analytics platforms that use today. So we support the 4 last major versions of Spark. Right, so the newest one is 3.1, but of course, because we're working with a lot of enterprises, people are still on 2.4, 2.3, so that's fully supported. Really, I think these are all the publicly supported versions of Databricks. Another thing we pay a lot of attention for is supporting for local development. Because one assumption that people make with SparkNLP, it only applies when you need a cluster, when you need to scale. Well, really, it's actually, most of the usage is on people's local machine, right? So, most data science, you just start on your local machine, you try some things and see if it works. And I'll show you some examples of that. So make sure, on Linux, on Mac, on Windows, it just works out of the box. If you need it Dockerized, it works. And we also looked at making sure it works with latest versions of Hadoop, Cloudera, Hortonworks, AWS, if you're on your SageMaker or on EMR, and the similar services on Azure and GCP. So the nice thing is, kind of wherever your environment is, you can assume at this point that there are multiple teams who are already using this in production, and people can help you online if you have any issues or trying to scale this, right, or trying to secure this in any way. So this is a quick overview of what the library does. And for here, we'll go and show you some code. So SparkNLP implements a fairly broad set of natural language understanding tasks, starting with kind of simpler ones like split text into sentences, do tokenization, do stemming, lemmatization, part of speech tagging, dependency, and spell checking and so forth. And then going to kind of the more interesting deep learning techniques, so whether it's name entity recognition, information extraction, normalization, emotion detection, spell checking is a deep learning problem. I think in the latest version, even sentence splitting is a deep learning problem if you work on cases where you do not have punctuation or you cannot rely on punctuation. Also, there are new tasks here on things like question disambiguation, question answering, translation, summarization. It's of course also done in a deep learning based way. The library, other than what you get, is there's the code and the API. So that's Python, Java, Scala. There's on top of that, there's also an ecosystem of models. As you can see, some of the transformers, and those transformers, and I don't know how many, in the few hundreds. Some of those, they come with the library. As you see, there's several hundred models and pre-trained pipelines that come as well. I think right now, this probably slides a bit out of date. We're at around 1,400, I think, models and pipelines with support for just over 200 languages. One of the benefits of having all of this within one library, right, so that you don't need to integrate with other libraries, is that it's twofold. One is just performance in terms of speed. Because whether you're running locally and you want Spark to just make the most of it on just 4 cores, or whether you're running it in a cluster, really you want one execution planner that, for example, loads transformers into memory, shares them across cores, distributes them across the clusters, minimizes things like shuffling and inter-node communication and all of that. So you want to do that from the very start, from how you do tokenization to the very end, which is how you calculate multiple embeddings and share them. So we do all of that at once, really by just having one unified pipeline. The other way where this seriously helps in really just in making your code more elegant, right? So instead of having to go saying, oh, I need Spacey for some of the basic stuff like part of speech and such, and I need Hugging Face to load transformers, and then I need to somehow put it in a pipeline, right? Or see how I load my data and such. Here you can really just have one pipeline where you load your data, you do the basic processing, you do more advanced stuff. It's all trainable. Once you're done, you have the models. The pipeline itself is serializable. So it's very easy to reproduce it. It's very easy to make sure that all the way you do training and inference is exactly the same in terms of data pre-processing, and really just get results faster. So with that, I want to show you some examples. Can you see the screen, the browser?
Yes. Yeah.
Okay.
Yes, I can see it.
Sure. So if you go to nlp.johnsonlabs.com, which is basically the basic, that's the first, Google search results. If you Google SparkNLP, you get kind of the project's homepage here. And there are a few interesting things. First of all, we have the full reference documentation. Right, if you're looking for, and SparkNLP is the open source piece, and then on top of it, we also have a data annotation tool. We have SparkNLP for healthcare, for biomedical and clinical NLP, and Spark OCR. And you have the installation instructions, and then of course the full implementation. There's a kind of a learning hub, which is what's interesting here is basically we collected, there's a whole bunch of videos, conference talks, articles, Medium articles, posts, notebooks, different experience. So you can see how to do different tasks, right? So for example, if you're interested in name entity recognition, see, just this is an overview, how to train your own models, how to achieve state-of-the-art results, right, with some code examples and some kind of some specific, this is a finance implementation, there are also some healthcare specific and other implementations. So that's the Learning Hub. And then there are two more interesting things here. One is this is your Models Hub, so you can search for models, right? So if you say, for example, so right now, as you can see, we have 1,459. But if you say, let's say you want to say, okay, what do we have in Arabic? So you can say, okay, we have 10 models and pipelines in Arabic. We have a part of speech. We have translation to and from English. We have neuron translation. This is the NMNT models. We have some name entity recognition, right? Word embeddings, Arabic specific embeddings, right? Parts of speech, lemmatization, and stop words, right? And then each one of these you can click, and you can you can see some results. You can see what, for example, what entities this is able to discover. You can see some example code. Okay, so this is kind of how you load the pre-trained pipeline. So you load first you load the pre-trained embeddings in Arabic, right? Then you load the pre-trained name entity recognizer, right? And then it shows you how you go and you annotate example text, right? You can see example results, and then it also for each model you have some metadata. Okay, so this, for example, is open source. It's officially supported. You can see the really kind of all the metadata you need, and we also we try to be as transparent as possible around the accuracy. Right. So here's the data we trained this on, and then here are the results that we achieved on the model. So you can easily compare this to other things and see if this is something that you're looking to use. So those are the models, and then the other thing you have is a set of live demos. Which is nice because what you have here is you have, I think it's right now it's about 110, 120 different Streamlit apps. And for each one of them, so let's say I'm looking to recognize entities from text. Okay, so you have the Streamlit app example. Okay, where you have about Jon Snow. Other than being king of the north, Jon Snow is an English physician and in the development of anesthesia and medical hygiene. He's considered to being the first one using data to cure cholera outbreak in it was actually 1854, but it's still a date. So this is an example where we apply a name entity recognition model, and a name entity recognizer in this case ran over this text and recognized three entities. It recognizes that Jon Snow is a person, that first is an ordinal, right, and 1834 is a date. And you can see other examples here and see what else can be recognized correctly. The nice thing about each of these examples is when you go here to the right, and you want to try it yourself, you can, for each one of these, there's a Colab notebook. Okay, and then you can just open it within your own, within your own Gmail account, your own Colab environment, right? Which is, which Google gives us for free. And then you have a full notebook that shows you, really shows you everything that's happening here. Shows you basically the code behind this example, everything from installation. And installation, by the way, it's basically it's a one-liner, right? So you run setup johnsonlabs.com/colab and just the best scripts, and it does everything that's needed. So that's the only one-liner. Then it installs everything it needs. We have this for Colab, we have this for Kaggle, we have this for other things. You do the import. This is how you start it. One important thing in this case, you see, we're just running it on Colab locally. You don't need to know anything about Apache Spark, no Spark APIs, nothing like that. You just do SparkNLP.start. That's it. In the background, it does what it needs, but you need to know nothing about it. We have the example text. We create a SparkNLP pipeline. So in this case, we create a document from the text. We tokenize it based on the model name, right? Basically, what you choose in the Streamlit app. You pick either onto 100 or NearDL. These are basically two models that the demo app shows you. And we load the correct word embeddings. So one of them uses GLAV embeddings. The NearDL BERT uses BERT embeddings, but you can see exactly which embeddings are used for what language. And then we actually load the pre-trained model, the pre-trained name entity recognizer. We put it in a pipeline and run it. Okay, so that's really as simple as it gets. Once you have an NLP pipeline, there are really two important methods: .fit to train and .transform to run inference, and that's it. Other than that, you can also write, you can save and load the pipeline, right? So once you fit it, right, you have a model, you can easily store it and then load it and do inference that way.
So we're at time, David. That is terrific. Thank you.
Sure.
So folks, so for follow-up, if folks have any questions, David, where would you want to send them for follow-up information?
Sure. One thing, I mean, you're welcome to contact me, just, email or LinkedIn. That's one way. Another thing to look, if you have just, there's a Slack channel, which is a SparkNLP, spark-nlp .slack.com. And if you go here, you go to just the NLP website. You have also the Slack channel from here, right here from the top right, and that's a really good place if you have if you want to paste code, you have a specific exception, you have question, because then we're there every day, just to answer people questions.
Awesome. Thank you so much for doing this. Hopefully folks learn something about it. This is a very complex field and a rapidly evolving field too. So everybody give David a physical or virtual round of applause. Good stuff. Thank you for doing this.
Thank you very much.
So next up, I'm going to do a tops of 5-minute explanation on the Cleveland Big Data blockchain challenge. And first, I also want to thank the Linux Foundation for letting us use their account, their Zoom account. So again, thank you to the Linux Foundation. We literally could not do this without you. And the recording of this this meetup is also going to be on the Linux Foundation ODPI website. I'm sorry, a YouTube account. My bad, on the YouTube account. So I'll as in other meetups, I'll post the link in the meetup site. All right. So I've been emailing. I'm going to start the timer now. I've been emailing about the blockchain challenge. Why have I been doing that? This is actually a serious challenge. I've been making some jokes about it, but it is actually, I think, an important topic. And the reason why I did it is from some personal experiences with blockchain. So for starters, there's the high level confusion, right? Cryptocurrency is not blockchain. Cryptocurrencies utilize blockchain, but not all blockchains are cryptocurrencies. and then there's also just hyper hype on it, which is, blockchain can do everything and it tastes great in a cracker, right? It's a floor wax, it's a breath mint. So let's dig under the hood and figure out what blockchain is and what it isn't. So for those, how many people are familiar with 5 levels, the Wired 5 level series? I'm a big fan, and for real. They had a really interesting talk about gravity. They had a pretty good one on quantum computing. They had one on blockchain, and this is an actual clip from the show. And I thought this lady was going to sell this kindergartner a timeshare. I was actually afraid for her. So yeah, it felt like Glengarry on blockchain. So it went on for 5 levels without actually explaining what blockchain was, which I found disappointing. Again, it's not a knock on the 5 levels in general, but it was a knock on this specific example. Another one that I personally experienced, this is an actual story that was in Healthcare Dive back in 2017, where it said IBM Watson and the FDA aim to tackle, tame, and blockchain for data exchange. And a couple customers saw this article when I was still back at IBM after the Exploris acquisition, and contacted us and said, so when can we get our blockchain? And if you notice, there are some very specific words that I've highlighted here in red. Meaningful collaboration and coordination, privacy concerns, lack of interoperability, issue of trustworthiness of data. And then the things they're advertising that they can fix with blockchain are continuity of the health record, longitudinal 360-degree view, providing health services to the patient. Like, these mean specific things in healthcare and should not be taken lightly. And so this is when I first started having to defensively learn about blockchain to find out what this was, and to talk the customers out of it. Lastly, there's a local story. So for those that may not be familiar with the Unify project, which changed its name to Unify Labs, this is an actual story. The Unify project wrote itself into the Amazon bid, saying that without doing anything, that they were already the top 5, in the top 5 regional selling points. They were going to improve the health of the region and drive solutions to poverty. This is actually true. They were going to help people live in prosperity and eradicate poverty and reshape the medical health care. And how are they going to do it? You guessed it, blockchain. This is an actually true story. And yeah, so blockchain's been showing up a lot. And so the question is like, what is it really? So this was an article. So for those that like computer security, Bruce Schneier wrote a great article on blockchain, and a great blog post back in 2018 to 2019. Again, I'd highly recommend folks take a look at it, where he was basically saying that the elements that are used in blockchains are foundational in computer science, and have been around for a long time. Consensus protocols and depend-only data structures. But basically, he was calling out a lot of the uses for blockchain as basically saying it's hype. Not to discount a lot of the individual elements, but a lot of people were saying that they were on blockchain simply for hype purposes. So that's why I put the challenge together. And with that, I'm actually right on time. I'd like to introduce Mark, who picked up the gauntlet for the blockchain challenge, and who will now tell me what blockchain is and what it isn't. So with that, Mark, I'd like to take it away.
Well, thank you very much, Doug. Let me share my screen here. Let me know when you can see something that looks like a presentation.
I think if you could switch the mode, because I'm seeing the presentation. I'm seeing the presentation.
Right. You're seeing the next slide.
Yeah.
Better?
There we go. Better.
Okay, anyway, thank you for this opportunity, everyone. It's a huge topic, so I'm going to spin through it rather quickly. And everything that Doug said is true. There are some amazingly dumb ideas that blockchain is layered on top of, and tries to make it into a pretty picture. So the question is, can I explain the blockchain challenge? Yes. That's the answer, right? So Q&A.
Presentation over.
Presentation over. Okay, no, just kidding. So let's talk. Like I say, I'm going to pare this down. You're getting the lawnmower version of what is really a very complicated motor engine. So I'm going to pare things down because it's easy to go down wormholes of jargon, but let's just focus on the basics. So first of all, like what you said, blockchain isn't Bitcoin. Bitcoin was the very first blockchain. There are other use cases for blockchain. So sometimes people conflate the two, and they're not necessarily the same. Blockchain also isn't bacon. You can't put blockchain on anything and turn it into a great idea. So bacon, makes soup better, sandwiches and pizza better, doesn't make everything better. Blockchain also isn't a database, and I'll pause there for a second for everyone to gasp. So you have this network, peer-to-peer network of databases, thousands or tens of thousands of databases, and I'm telling you, this is not a database solution. Okay, so what is it then? Well, the purpose of blockchain is to solve a trust problem. It's not a data problem that it's trying to solve, it's a trust problem. So think back to Bitcoin, where the problem they were trying to solve is they didn't want to trust a central bank, whether it's in the United States or any other country. They didn't want a government controlling the currency. They wanted a peer federated control of the currency. And the way they did that was they came up with a peer-to-peer network of databases. This doesn't show the peering, but it shows that they are scattered all over the world. And you might have some bad actors here and there. These are little people in prison costumes. So even if you have this network of thousands or tens of thousands of databases with some people who are malicious, overall, there are incentives built into the algorithm that make it to most people's advantage to come up with the correct answer. So you can trust the outcome of this algorithm, even though you might not trust every one of the participants. So the core attributes of any blockchain, not just cryptocurrency, but any other type of blockchain, are one that has a group of transactions. So this is basically an immutable transaction ledger, and that transaction might have a little bit of data in it, or it might have a pointer to data that's stored somewhere else. And I'm purposely ambiguous right now about where that somewhere else is. Blockchains also have a Merkle tree, which is based on hashing, and I'll demonstrate this in just a minute, but it's a hash of all the blocks, transactions, and the metadata. And you link each block of transaction. Now think of block as basically a giant record. All these data records are linked together by a hash. So if someone maliciously does something to one of the transactions, it's tamper evident, and everyone else downstream in time can see that that was not a legitimate vote. There are also distributed copies of all these blocks. And the consensus algorithm, generally 51% of the participants have to do something and prove that a block is good. And if 51% say the Earth is flat, then it's flat. That's the accepted truth. But if 51% agree, then that is the agreement. And that's the core attribute of any type of blockchain. So we'll dive into each of those a little bit. But I do want to talk about security.
Yeah, we just lost you. I mean, I can see you're sharing something, but not the presentation.
Yeah. Can you see it now?
There you go. Yep, you're back up.
Hopefully you don't see this little, okay, link it. So security, we all hear that blockchain is secure. It's secure, it's secure. Okay, so because people hear the word security, they try to throw it at anything where security might be beneficial. But security doesn't mean private. What it does mean is that you have consistent data, it's agreed upon, and it's immutable. And those are good attributes. But security, just like this guy in the armor here, is not absolute, right? We could come at him with a bigger army or better weapons, and all of a sudden, the security does not meet the threat. So security is not an absolute. Sometimes it's a trade-off between speed and security. And the idea of consensus algorithms is that a 51% attack is theoretically impossible, but it has in fact happened on the Ethereum Classic network. You can look that up. But something that's supposed to be, oh, that could never happen. Well, it actually did. And there's some reasons why, but you have to understand that when you're buying into this security word, there are some little footnotes. And by the way, don't put encrypted data on a blockchain. So if you think the data is so important that you want to encrypt it, put it somewhere else. So no confidential, highly sensitive information or personally identifiable information. Because this data is immutable, it has a very long time frame for people to play with it. And maybe someday they'll figure out how to unencrypt it. So that is not where you want to store sensitive data. Okay, I'm going to do a quick demo. I'm going to switch over to my browser. What we're going to see in the browser is, and I didn't write this, but it's a nice little site. It's going to show you how the hashing works and what happens if you break the data. Oops. Okay. Can you still see my screen?
Yep, I can see it.
Okay, good. So so here we've got the block number, a nonce, which is a number that occurs once, and we have our data. So imagine that this is a set of data transactions, and data is typically just a clump of JSON data. And there's some various components that go into that, but just let's make it real simple. If I type in my data here, my transaction, notice how everything turned red. I'm going to hit mine, which is going to solve a mathematical puzzle, which is going to force the hash to start with 4 leading zeros, which is tough to do. And the way that it did that was it just tried all different combinations of this nonce value until it could solve the puzzle. But now all the downstream ones are broken. So let's just solve this one. I won't solve them all. But I just want to show, if I go back to this one and change the data, I just put a 4 after my ABCD. This block now knows that this hash is invalid. And the subsequent block, block number 2, says, hey, that previous block was no good. So it's very tamper evident. It's very easy to use some cryptography to see what's going on and to know good data from bad data. So let's go back to here. So here's a little code I wrote just to show you what's going on. If you were paying careful attention, you would have noticed that the calculated nonce value for ABCD, that's our transaction, was 47019. So if we concatenate all these together and perform a hash, a SHA-256 hash, we get the exact result that was shown in the website. But that's not really how the hashing should be done. But that web example did do a good job of showing how the hashes chain together and how if you change the data in one block, it invalidates that block and all the subsequent blocks. So it did a great job of that. But what it did was it just concatenated all of the data. It treated all of the transactions as a single entity. But really what's needed is Merkle trees. So with a Merkle tree, you still get the same overall result in that the block hash will represent whether the data inside of it is good. But the way it's supposed to be calculated is you calculate the hash of each transaction, and then you take 2 transactions, concatenate their hashes, and hash that to a value. Same with the C and D, you concatenate that, and then you just keep, it's just kind of like a playoff bracket. You just calculate all the hashes, and you come up with one net hash, so that if anything in any transaction were to change, this root hash would be broken. And really, the Merkle trees, I think that's really the hashing, the fact that you can hash any data set and come up with a unique value that proves that the data matches the hash. That's the real core essence of a blockchain. So let's recap some words. So a block is a group of transactions. These transactions, especially in things other than crypto networks, might not be related to each other. So you could have a transaction for one type of application, say supply chain, and then a transaction for I don't know, agriculture or something, who knows, in the same block. So just because the transaction is in a block doesn't mean it has anything to do with any of its peer transactions. It's just a bunch of data. So the chain is that cryptographic key that links everything together. So as we saw, any change in the data will break the chain. And each of these blocks is distributed out to many thousands of nodes. Depending on the network, there will be different number, but in the case of Bitcoin, it's around over 80,000 copies of the database. This is not a sharded database. This is 80,000 full copies of the database. So it is a distributed ledger, and it's those database holders who are doing the validation and coming to a consensus on what the next new block is. And they're using some type of consensus algorithm. There are various types of consensus algorithm. The one that chews up all the electricity that people say is killing the planet, true statement, actually true fact, is proof of work. So that's the one that just requires enormous amounts of electricity, and that's what most crypto currencies use. So where is the data? Well, it's everywhere. If you remember back to that original map of databases spread around the world, that is literally what it looks like. So you have thousands or tens of thousands of copies of the database, and you could have one too. You could go home tonight, or you might be home, download the entire Bitcoin network. You have it on your computer, and now you can start grabbing data from it. So it's a full database. Got to point out here, keep in mind, this is not a data solution. This is a trust solution. Blockchain throughput is extremely slow compared to any database. It's, in terms of throughput, it's the world's worst database. It's not designed for that. You can store, as I mentioned, a small amount of data on the chain. For instance, in Bitcoin, there's an op return field, and you can store up to 80 bytes. So you could put a hash in there, and that hash could point to a data file that resides somewhere else. But you're just not going to be able to store a large amount of data on the chain. For that, you could store it in public cloud storage of your choice if you want a central solution, or if you want something decentralized, you could do the interplanetary file system. Yes, that's a real name. But the data that's on the blockchain is really just flat files, and the data that it points to, if you have data off chain, is really just flat files. You don't have indices. You don't have any of the things that make querying useful or possible. So I kind of talked through this already, but in terms of cost, so on-chain storage is super expensive. You wouldn't do it. You just would not do it. For Bitcoin, it costs, I think it's around $20 million to write a gigabyte of data. For Ethereum, another public permissionless blockchain, would cost about $60 million to write a gig of data. Hyperledger is a private permissioned. So with public blockchains, you can sign up and say, "Yep, I want to be, a particular."
Mark, you're starting to cut out. Could you back up just maybe 10 or 15 seconds?
Yeah, sure. That might be my voice. I'm trying to talk so quickly here. So I was talking about how expensive it is to write the blockchains, millions or tens of millions of dollars to write just a gig of data. So that alone makes it prohibitive for storing, application data on it. And these Bitcoin and Ethereum are public permissionless blockchains. So anyone could, sign up and do it. You don't need someone's permission. You don't need to fill out a form or anything. You just download the stuff and start doing it. No one can stop you. The consensus algorithm might, not like the answers you come up with if you're malicious, but you can just jump in anytime you want. Hyperledgers are private and permissioned. they have a relatively low number of organizations per network. Bitcoin, Ethereum, and Hyperledger basically use level DB, or in case of Hyperledger could also be CouchDB for the blockchain data. So these are really primitive databases, not too cool. For Hyperledger, you can get a roll-up of all the current state stuff. It's called world state, and put that in the relational database of your choice. The others don't have that. You might be able to build one yourself, but querying is not really super easy. So where's the API? Well, because the data could be anywhere. Well, there's no central authority that is giving you an API. Think about if you have a public permissionless blockchain, you've got the data. Why do you need an API? And if you really want one, go write one. There are a bunch of open source projects that will get you started. So there's something with already. But key point: there's no central authority that produces the documentation and the API. This is distributed, and if you feel for your use, do it. If you feel like an API, then don't. You can just go directly at the database. I want to talk about Spark contracts really quickly because this is where a lot of business value potentially comes in. Spark contracts allow business-to-business process automation, and much like this vending machine, they're a state machine. So think about this vending machine. You walk up to it, and the product has to be available. You have to present sufficient payment, make a selection, and then that triggers something, and it triggers a transfer of an asset from the seller to the buyer, and it returns some change to you. And smart contracts really work the same way. And I'm going to pick an example here. I like to pick on this company. They're no longer in business, but we can still look at their data and their transactions because it's immutable. The data never goes away, even though the company did, and there's no need for this data anymore. You just can't get rid of it. Let's see. So let's take a look. There's so much stuff I have to skip here. Anyway, so this is a company called Fizzy. They were selling flight insurance. So if your flight was more than a couple hours late and you bought a policy, they'd pay you on it. So we can look at all these transactions here. And you can even see, okay, this was a flight ID and the actual arrival time. So there's a lot of transactions like this where it's just updating flight status. Here is one of their transactions I found that's pretty fun, at least for me. It's showing the limit on the, this is basically the policy. So it's showing you the premium. This is how much revenue they collected, and this is how much revenue they would pay out if the flight is late. So, think about security. I'm looking at their finances, basically. I'm looking to see how many policies they sold, how much premium they collected, and if I do enough digging, I can figure out how much they paid out too. So does that meet your model of security? It's very transparent.
And Mark, so this is on-chain data, right? So everything we're looking at right now was data that was actually in the ledger, right?
Yep, this is in the Ethereum blockchain. It's on the chain. It's immutable. You can't get rid of it, even though the company went out of business. So the other thing about, oops, where is it? So if we go back to this Fizzy, so think about, okay, does this meet your idea of security? I clicked on a button contract here, so it's Spark contract. In Hyperledger, they would call it chain code. The same kind of thing, but you have a script which has all of your functions in here and all their arguments. So I could look at the source code of this, and if I were a malicious person, I could execute code against this privately to see what would be successful and then launch my attack publicly. So, is that really secure? I don't know. It's transparent for sure, but it's a kind of a different mindset to security. Okay, can you still see my screen? You should see a presentation now.
Yep, we've got like 30 seconds left.
Okay, I had so many more things I could demo, but I'll wrap it up by saying this. So blockchain use cases. There are a lot of good use cases where you could use blockchain transactions, cryptocurrency and asset transfer, smart contracts, which are really have some degree of traction in the supply chain space, tokenization of assets like non-fungible artwork, non-fungible NFT is non-fungible token. There's some traction with identity management. So there are some ways that blockchain could make things better, but it doesn't make everything better like Bacon does. For me as an IT professional, a blockchain is a lot like a metric Allen wrench set. I have one of those in my basement. I don't run around my house trying to figure out how to use the metric Allen wrenches. Sometimes if I'm tightening IKEA furniture or the roof rack on a car, it works perfectly. If I'm doing other things, it's not my tool of choice. So that, unless you want to go into some demos, but it sounds like I'm at time, I will leave it there.
That is terrific. Mark, thank you so much. You have won the blockchain challenge.
Thank you.
You've successfully explained it to me. Thank you very much. I enjoyed it. Let's everybody give Mark a virtual or physical round of applause. I know you put in a lot of work on this. Thank you.
Thank you.
Yeah, I think that's it for tonight. And again, thanks for everybody for attending, and we'll look forward to the July meetup. Thanks everybody. Stay safe. Have a good night.
Thank you, Doug.
Thanks everyone.